Hi there, in this video you're going to learn how to graph proportional relationships. Your objectives for today are obviously to graph proportional relationships and to identify proportional relationships by graphing. So first of all, you need to figure out how to identify proportional relationship. So there are two criteria. One is it needs to go through the origin, and the second is it needs to be a straight line. If it goes to the origin and if it's a straight line, then yes, it is a proportional relationship. Let's look at our first example. The slowest mammal on Earth is a tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. So first thing we're going to do is we're going to make a table to find the number of feet walked for 0, 1, 2, 3, and 4 minutes. Okay? In 0 minutes, it's not moving, right? In 1 minute, it moves 6 feet per minute. So in 1 minute, it moves 6 feet. 2 minutes, it would move 12 feet, right? It moves 6 feet per minute. In 3 minutes, it would move 18 feet. And in 4 minutes, it would move 24 feet. Each time, I'm adding a distance of 6 feet. All right? Now we're going to graph the ordered pairs on the coordinate plane. Then connect the ordered pairs. So remember, this is X. This is Y. We're going to graph 0, 0 right here. 1, 6 is right here. 2, 12 is right here. 3, 18, 3, 18, and 4, 24, 4, 24. Graph the ordered pairs, and then you want to connect them. So you want to look at our two criteria. Is it a straight line, right? These are our criteria. It needs to go to the origin, and it needs to be a straight line. This is a straight line, and it goes to the origin. So since it goes to the origin and it's a straight line, the number of feet traveled is proportional to the number of minutes. Here's our next example. James earns $5 an hour babysitting. Determine whether the amount of money James earns babysitting is proportional to the number of hours he babysits by graphing on the coordinate plane. Explain your reasoning down here. I'm going to call this the work zone here. All right. So first we have $5 an hour babysitting. If he doesn't babysit, he doesn't make any money, right? So at 0, it'll be 0, 0. $5 for the first hour. After 2 hours, if he makes $5 an hour, he would make $10. At 3 hours, he would make $15, and so on. So once you plot these points, right, you're just going to draw a line. You're going to draw a line to connect the points. So here, I'm just going to draw a line to connect my points. All right, is this a straight line? Yeah, it is. Minus this little piece over here, but that's because I can't draw right on the Chromebook. So yes, it is a straight line, and yes, it goes to the origin. So since it's a straight line and it goes to the origin, the relationship is proportional. All right, so let's look at our next example. The cost of renting video games from Games Inc. is shown in the table. So you're given this table. Determine whether the cost is proportional to the number of games rented by graphing on the coordinate plane. Explain your reasoning. All right, so first, we want to get started with this, using this chart. So I have the number of games. If you buy 1 game, it costs $3. If you buy 2 games, or I should say rent games, right? If you rent 2 games, it's $5. So 1 game is $3, 2 games is $5. 3 games is $7. 4 games is $9. All right, and if you're not sure how to read straight across here with this table, just write out your ordered pairs, and that's easier. 1, 3, 2, 5, 3, 7, 4, 9. That's how we got to this graph. Now, we graph 1, 2, 3, and 4 points, right? Because there's 4 points here. Now, How did I know that the next point wouldn't be at 0, 0? How did I know that it was going to be here? Well, think about it. You're going down 2 and to the left 1. Down 2 to the left 1. Or you could think of it as up 2, right 1, up 2, right 1, right? So here we would just continue this pattern. So you could even look here, right? 1, 2, 3, 4. If we put a 0 here, what would the cost be? Well, you're changing by 2 here, right? 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9, right? So if we added a 0 here, 3 minus 2 would be 1. So this ordered pair that would be here would be 0, 1. Okay? So the line doesn't go through the origin, so this is not proportional. Okay? So even though it's straight, it doesn't go through the origin, so it's not proportional. And let's look at this next example. The table shows the number of calories an athlete burns per minute of exercise. Determine whether the number of calories burned is proportional to the number of minutes by graphing on the coordinate plane. Explain your reasoning. All right, so first we start off with 0, 0. Let's graph that right there. All right, next needs to be bigger. Okay, first we start off with 0, 0. Next we have 1, 4. So in 1 minute, up 4 calories. In 2 minutes, you're up 8 calories. 2 minutes, 8 calories. And then in 3 minutes, you're up 13 calories. All right. So now we're going to graph, or I should say now we're going to connect the points. Okay, well, if you look here, I actually can't graph a straight line. If I were to graph a straight line, it would actually be under this point, right? So this doesn't end up being a straight line. So since this is not a straight line, even though it passes through the origin, this is not proportional. Since this is not a straight line, the relationship is not proportional. All right, and if you're not sure, just look. From here to this, from this point to this point, right? You're going up 2, 4, right? You're going up 4 to the right 1. Up 4, right 1. Here you're going up 2, 4, and then 5 to the right 1. So that is why this graph here doesn't show a proportional relationship. Also, if you want to just double check yourself, you can do the ratios, right? 1, 4, 2, 8, 3, 13. 1, 4, and 2, 8 reduce down to the same ratios, but 3, 13 doesn't. So, yep, that's why this is not proportional. It's not a straight line. All right, which batting cage represents a proportional relationship between the number of pitches thrown and the cost? Explain. So here we have softball plus, and here we have fun center. What our two criteria again are straight line and origin, right? So which one of these has a straight line and goes to the origin? The graph for softball plus is a straight line, but it doesn't pass through the origin. So this is not a proportional relationship. The graph for fun center, which is right here, is a straight line through the origin, so the relationship between the number of pitches thrown and the cost is proportional. All right, so just some concluding thoughts, or really one concluding thought. If it is a straight line and goes to the origin, it is proportional. All right, that's all you need to know for today. I hope you learned about graphing proportional relationships. Thank you for watching.